Hello, my name is Katie Munson, and I would like to welcome you to another video for MCDB 427, which is molecular biology at the University of Michigan. The figures in this presentation are from the book Molecular Biology, written by Robert F. Weaver, and the video we will be discussing is figure 15.6, which shows the effect of the 5' cap on reovirus RNA stability. First, here's a picture of an mRNA with a 5' cap attached. A 5' cap is a methylated guanine which is attached to mRNA through a 5' to 5' linkage. Therefore, there is an alpha phosphate from the methylated guanine, then a beta phosphate and an alpha phosphate from the RNA. This specific linkage is found nowhere else in the RNA. Therefore, it was believed that the cap might protect the mRNA from RNAses that begin at the 5' end of their substrates and that cannot cleave triphosphate linkages. Next, we'll go over some background information regarding the main functions of 5' caps. 5' caps protect mRNAs from degradation, enhance the translatability of mRNAs, enhance the transport of mRNAs from the nucleus into the cytoplasm, and enhance the efficiency of splicing of mRNAs. In this video, we will discuss a figure which shows how the 5' cap protects mRNA from degradation, so we will focus on the first function listed. Scientists suspected that 5' caps may protect mRNA from degradation. Therefore, they tested the effect of the cap on RNA stability. They synthesized reovirus RNA in the presence of 32-phosphate alpha phosphate ATP to label the RNA. There were 3 different types of RNAs made: fully capped, blocked, and nothing added. For the RNAs that were capped or blocked, this capping and blocking occurred after synthesizing the labeled RNA. The fully capped RNAs have the full methylated guanine added to the 5' end of the RNAs. The blocked RNA have a guanine, which isn't methylated, added to the 5' end of the RNAs. Finally, the third type of RNA is uncapped and has nothing added to its 5' end. Next, each of the 3 kinds of RNA were injected into Xenopus oocytes and were removed after 8 hours. This was performed for graph B. Graph A skips this step and does not involve the injection of RNA into oocytes. It simply involves synthesizing the RNA and analyzing it with glycerol gradient ultracentrifugation. Finally, the RNAs for both graphs A and B were purified and analyzed with this glycerol gradient and ultracentrifugation, which separates the RNAs based on their relative densities. All of the fractions of this gradient were analyzed by measuring the amount of radioactivity for each fraction. Each dot on the graph represents the amount of radioactivity present in each fraction. This radioactivity is correlated with the amount of mRNA present in each fraction because it is radio-labeled. The green line represents the labeled reovirus RNA with capped 5' ends. The blue line represents the labeled reovirus RNAs with blocked 5' ends. Finally, the red line shows the labeled reovirus RNAs with uncapped 5' ends. Note that both of these graphs show 3 separate gradients with the data overlaid onto one figure to easily compare the mRNA types. The labeled L, M, and S on the graph represent the 3 size classes of this specific RNA and are marked here. Graph A shows the labeled RNAs after being subjected to glycerol gradient ultracentrifugation. The RNAs were not injected into oocytes. They were simply synthesized and then ultracentrifuged. No significant differences in the amount of RNA can be seen here, and each of the 3 size classes is clearly visible. This graph serves as a good comparison for the next graph, in which degradation of all of the RNAs was seen. Graph B shows the labeled RNAs after being injected into oocytes for 8 hours and then subjected to glycerol gradient ultracentrifugation. All 3 types of RNAs suffered degradation when compared to graph A. Degradation was highly pronounced for uncapped RNAs, shown by the red line. So based on these figures, there are a few conclusions that can be drawn. First, Xenopus oocytes contain nucleases that degrade the viral RNAs. After the RNAs were injected into the oocytes, degradation of all of the RNAs occurred, especially for the uncapped RNAs. The RNAs that were capped appeared to provide some protection against these nucleases. Finally, this demonstrates that capped RNAs are much more stable than uncapped RNAs. Thank you for watching, good luck with your studies, and go blue!